All right, so in this video, we're once again looking at an octagon that's inscribed in a circle. The circle still has a radius of 3, so you watch the one with the area, there's going to be a lot of similarities here. But this time, I want to know the perimeter of my octagon inside of this circle. So in order to find the perimeter, what we're really looking for is simply what are the sum of the lengths of all the sides. So knowing that this has a radius of 3 and it's an octagon, I need to be able to find what is the length of one of the sides. Now, there are multiple different ways that you can go about doing this. For today, I'm going to be using right angle trig in order to help us out to find the length of this side. So I'm going to highlight the side that we're looking for. This is what we're looking for right here. And I'm going to call this L. I know that the perimeter is going to be L times N. L is the length of the side, and N is how many sides I have. Because this is a circle, we know that each of the triangles that could be drawn are all going to be congruent, so they're all going to have the same lengths and the same angle between them. If I were to go around the entire circle, that's 360 degrees, and I have 1, 2, 3, 4, 5, 6, 7, 8 of these triangles I could draw because I have 8 sides to my octagon. So this larger angle at the top is going to be theta, which is 360, divided by my number of sides, which is 8, which gives me 45 degrees. I'm not going to write that in yet because I'm going to zoom in and look at this triangle, and we're actually going to break it up even more. So the first thing I'm going to do is I'm going to drop a height. Now, very specifically, a height or an altitude is dropped from a vertex to the other side, and it meets at a 90-degree angle. Because it meets at a 90-degree angle, I can go ahead and use right angle trig on this triangle here. Some other pieces of information that I know is because my circle has a radius of 3, I know that this line here and this line here also have a length of 3. You might be thinking, well, I only needed this one if this is the triangle that I'm going to solve, which is partly true. But one of the important things of knowing that both this side and this side is 3 is knowing that I've created an isosceles triangle, which means that 2 of the side lengths are the same. In an isosceles triangle and an equilateral triangle, when you drop your height down like this, you actually split the angle up here, this vertex angle is sometimes called, perfectly in half. For triangles that are just oblique, if that isn't isosceles or equilateral, that's not going to be true. But for an isosceles or an equilateral one, when you drop a height, you split the angle perfectly in half. So we can come in and say, okay, if this larger angle is 45, well, 45 divided by 2 is 22.5. So this small angle here is 22.5 degrees. This has all been the setup to try and find the length. I now have enough information looking at said triangle to be able to find what I'm going to label X right here. If this is my right triangle, I have this angle. 3 is going to represent the hypotenuse because it's across from my 90-degree angle. X is all the way across from the angle I have, so it's going to be considered my opposite side. I want my opposite, I have my hypotenuse, which means I can use the sine function. So I can say the sine of my angle is going to be equal to x over 3, and I can multiply this 3 up to the other side. So x is equal to 3 times the sine of 22.5 degrees. At this point, I could go ahead and put this in my calculator, but I'm going to leave it as such so we can see how all these pieces build. X is not L. X was only half of this length. Once again, I know it's exactly half because this was an isosceles triangle. For an isosceles and an equilateral, when you drop the height, it splits the angle in half, and it splits this side in half. For other types of triangles, that's not going to be the case. But it was an isosceles, so this is perfectly split in half. So L is going to be equal to double X. So L is going to be equal to x plus x, or L is equal to 2x. So I'm going to take this quantity and I'm going to double it in order to get L. L is going to be equal to 2 times the 3 times sine of 22.5 degrees. I'm going to go ahead and put that in my calculator now. 2 times 3 times the sine of 22.5. And I found out that the length of one side of my octagon is approximately 2.296 units long. We said that in order to get our perimeter, we need the length of one side, and then we need to multiply by the number of sides I have. So I have 8 because it's an octagon. So my perimeter is going to be equal to that number times 8. And we get a perimeter of 18.39 units. So there you have it. Once again, this can work for any polygon that is inscribed in a circle. The only things that would change is the radius length. So when you multiplied by 3 here, that was equal to the radius. The other thing that would change is your angle. I got this angle by dividing 360 by the number of sides and then splitting that number in half. And then also at the very last step, in order to go from the length to the perimeter, I multiplied by 8 because this is an octagon. You simply multiply by the number of sides of the shape that you have.